Hey guys, welcome back to another day. Um, I realized that yesterday I did everything before 7 p.m. here, and let's get started on this. We're starting the link list section, but I realized that I lost my streak because, yeah, it resets on 7 p.m. and I didn't get home until like 9, and then I had to go somewhere else again. So, it's whatever. At least this year's almost over. I'm hoping next year I'll see a lot more consistency than this, hopefully. Like all this just to do 57 problems, like come on. Alright. Anyways, let's get started with the reverse linked list. Uh, Given the head of a single linked list, reverse the list and return the reverse list. So I'm just checking out my wrist. Alright. Uh Alright, given a head, reverse the list and return the reverse list. Um, let's see, how do we do this? So I think we would want a temporary pointer to the next element. Let's see. So say we're at 1, right? We have 2 is the next node. Do we set 2's next equal to 1? And then we have 3. We set 3 equal to 2. And then I'm not gonna lie, I'm not too good with linked lists. So I'm gonna do my best here. My back is so itchy. Was it? Curry goes head. Wow, Kurt? Or is it wow, Kurt dot next? Wow, Kurt. Yeah, it should be Kurt. Kurt equals Kurt dot next. No. like a previous. Oh, can't change that yet. Tempe goes cur dot. Tempe goes cur dot next. Cur dot next was previous, and then previous equals cur. Cur equals temp. When I get to the end, and then return cur. Shoot. I feel like this is just a simple trick to remember, but why don't I remember? How about return pre? Oh, let's go. Okay. To be honest, I don't know how I got it. I remember doing something like this in my other class, but that was just to like initialize a doubly linked list. Uh, see. Okay, I'll take it. Why was I doing an algorithm with this? Because I remember I had to initialize a previous pointer for my class, but I don't think the use of it was to reverse this linked list. It was probably a doubly linked list. Um, what did I do before? Damn, Helix. I attempted this hella times. What'd I do? I forgot. If not head, then you would just return. Is this the exact same thing that I did? Wow. Holy shit. Well, I'm glad. I remember before I low key had to like look at the answer. I'm glad I was able to think of it on my own. Even though it's an easy problem. That's always good to see. Dang, can't believe they were like the exact same except for that edge case where it was empty. But I guess this still works. Um, Tempe and like same variable names is crazy. Okay. Um, Merge two sorted lists. Put on some music. Wait. One. I okay, don't get this problem. Merge the two lists into one sorted list. Oh, one sorted list. And both of them are non-decreasing order. Hmm. Hmm. Should I just create a new list? Oh. Yeah. I don't think I'm starting this right. No, I don't think that's right. Damn, am I tripping? This isn't easy. It's just the loop through. I, I'm gonna have to watch the. Wow.
Hey guys, it's me
Stupid
again, and let's solve
recursion.
another LeetCode problem, merge two
Okay,
sorted
I'm
lists. So
not
this is
thinking
an
about recursion.
easy problem. It's
Man.
a mainly fundamental problem. There's nothing crazy about it, but it's a pretty good problem to understand some basic stuff. So we're given two linked lists, right? So this is the first one, this is the second one. Both of them are already sorted, and we just want to merge them into an output linked list. The only catch is that we have to use the original nodes, right? Like we can't create copies of the nodes. So let's say we have list 1, and we have list 2. I'm just going to take them exactly from the example that they gave us so we can actually focus on the general algorithm itself. So your intuition will probably solve this problem for you. So it's basically, since the lists are sorted, we start at the beginning of both of them, right? Now we can just compare the values. So they're both 1, so it doesn't really matter which one we pick. So we can just take, I'll say list 1, right? So we'll take this one and insert it in our output and then move to the next one. And then just continue the algorithm. The only catch here is that right now our output list is empty, right? So this kind of gives us an edge case because we don't even have a list itself yet. So what I like to do is just create like a dummy node. So this is a pretty common technique, and you avoid any edge cases. You avoid the edge case of the initial empty list. So let's say we start out with a list, right? This is a dummy node. It can have any possible value. So now we're going to insert 1 into our list. Now we're going to compare two values of 2 and 1. In this case, the value from list 2 is smaller, so we're going to take it, insert it into our output list, 1. Now we're going to be comparing these two, so 2 and 3. The value from list 1 is smaller. We take it and insert it into our output, 2. And then, of course, we can move to the last value in list 1. So now we're at 4 and 3. Which one of them is smaller? Of course, 3, which is the value in list 2. I'm running out of space, but I think you get the idea at this point. So now we're at the two last values from each list. We'll just take the value from list 1 and add it, which is 4. They're both the same, so it doesn't matter. Now, this is the last edge case that we have to worry about. So now, for list 1, there aren't any more values left, right? So we can't really continue our algorithm. Lucky for us, there's only one value left in list 2, but it's not always going to be the case, right? Maybe there could be a bunch of other values, right? 4, 5, 6. There could be other values in list 2. Now, what would we do in this case? Well, we can do a really easy thing, which is just take the remaining portion of the list. So if we run out, so if one of the lists is empty, of course, the list 2 in this case is still sorted. So we can literally just take that list, insert it into the end of our result, right? So that's basically the idea. Okay, now let's write the code. So remember, I like, and most people like to use this technique of creating a dummy node, so you don't have to worry about the edge case of inserting into an empty list. The tail of our list is initially, I'm just going to say, the dummy. So now we're going to keep going. We're going to iterate through these two lists. What's the condition that we're going to do that? Basically, if both of them are non-empty, right? Because that's when we can actually compare the two values. So while list 1 and list 2 are non-null. So now we can do our comparison. So if the value of list 1 is less than the value of list 2, then of course we're going to take the list 1 value and insert it into our tail. So tail.next is going to be the node itself, right? List 1 node. And then we can, of course, update our list 1 pointer.
Smart, using a dummy node. I guess we don't need this because we... Should do this, right? So we iterate dummy to the next one after. If this one, then dummy dot next. Okay. Oh, tail equals, yeah, I should have done that. Because then we have to return dummy dot next, which gives us the actual head. Okay. I'm stupid. That trick with the dummy node is very useful. Okay, so basically, we create a dummy node. We set a tail equal to the dummy so we can add it on without losing the start, right? Which is this dummy. And then while list1 and list2 is basically what he said. We add the minimum or like the smaller number, and then we yeah, so we add the smaller number to the tail, and then we iterate through the list, like through the respective list, right? So if list one is smaller, we move on to the next list one object. If list two is smaller, then we move on to the next list two object, and then we have to iterate the tail of the one we're adding to because we want to keep adding it to the end, right? And then basically what he said, if list one or list two is not null, that means there's some elements left, right? But because it's sorted, we can straight up just add the whole list to the end, which is what we do here. And then we return w.next because the first node, remember, is null. And that's it. Do not return anything, modify head in place instead. What the hell? Damn, my back is hella itchy. So I'm thinking. What am I thinking? I'm thinking we use a tail pointer, or we have two pointers, one at the beginning and one at the end, and then we just keep alternating. So head.next equals tail, um, tail. I keep seeing this. LeetCoder is studying this problem currently. How many people are on Leet? Wait. Given the head of a single linked list. I don't think that would work. Modify it in place. Does it not work? You have a pointer on the left and the right. Let's see this. Fuck. Alright, bro. I'll just log in. Damn. Okay, so let's see. Currently, we have our head. Let's label this head. Then we can reach tail. So head goes to tail. No. Cur equals head. Fuck. Let's call this. No, let's just do head. Head equals list one. No. Let's call this cur. Head, and we go cur, and this becomes tail. We go cur equals head again, and then cur dot next equals tail. And then fuck. No. Let's call this end for tail. Because then I want to do temp here. So we do cur, or temp equals cur dot next, and then we go cur dot next equals end. End dot next. Would you need a previous? I think you would. So you would create like a doubly linked list, I think. And then end. So then T2 or whatever, but then you have that and then N. I guess you wouldn't need a T2. You could just do E dot next equals that, and then T equals E dot previous, which is this. So curve equals head. No, let's do So in while cur, we do fuck. But there's no previous attribute, is there? Yeah. So this is a singly linked list. Oh, fuck. So we have cur equals head, and then we get to the end. We mark that as the end. Cur equals end. Cur dot next equals end. Mm. So you can't have a previous pointer because we have a singly list node. Dude, what? Okay, I have no idea, man. Mm. So we have curve, we get end. Maybe end for next. So like curve for that, then this is here. Am I lagging? Is my laptop lagging? So you take, so we have an n, set that equal to cur dot next. Let's just do tail. Fuck. How am I gonna update tail though? Cause okay, I genuinely don't have an idea. Like I kind of do, but
Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem reorder list. So we haven't done a linked list problem in a while, and this is a pretty common and interesting linked list problem. So we are given the head of a singly linked list, where we have the first value, the next value, etc., and we want to rearrange it into this order. And a better example would be, so for example, take this linked list, and we have 1, 2, 3, 4. That's a straightforward ordering, but we want to take the first value, leave it here, then take the last value, move it in the second position. Then the second value gets pushed forward, and then the third value is going to go next. And so in other words, what we want to do is, given the original list, we want to take, the first value, put it in the first position, then take the last value, put it in the next position, then take another value from the beginning of the list, put it in the next position, then take another value from the end of a list, and keep doing that. So basically, we're alternating between the beginning and the end, and we're continuing to pick nodes, and then building a new linked list. So just like the problem name, we're just reordering this list.
Came out
Hey everyone, welcome
3 years ago. Can I check who liked it? 11,000. Oh shit. Damn, I got that popular.
back and let's write some more neat code today. So today list, we're not actually going to be creating new nodes. We just want to take each node and then put it in the correct position in the output string. And then we don't have to return anything because we're just modifying this list in place. So there are many ways to do this problem. I'm going to be focusing on the solution that we can do in linear time. Basically, n is the size of the linked list, but we're going to do this without any extra space. And it's not too difficult to do this with extra space, but without extra space, it's a little bit more tricky, but it's also pretty doable. So that's what I'm going to be focusing on. So if we were using extra space, what we actually could do is take this entire thing and put it in an array. So each node goes in the array. And what we would do is we would take the first portion, leave it as it is, and then we would take the second portion and either reverse this entire portion or just go through it in reverse order. So, something like this, having one printer.
Holy shit. How do you get that? Reversing it, huh? That's smart. So maybe we just yeah, so we split it into two halves and reverse the second portion, and then we um we just alternate heads, like 1, 2, from list 1, then list 2, then list 1, and then list 2. Oh. Okay. Let me try this. I forgot how to do these I know you do like a slow fast pointer, so do they start at the same one? This would be one, one, and then I go next, next. This would be next, next, next. Okay, I think so. Right. Okay, so we should have gotten half there, and then we, um, from there reverse it. Or maybe we just want to get it to the second half, so head next, and then slow. So wow. So wow, cur. Temp equals cur dot next. Cur dot next equals cur dot next equals prev. Prev equals cur, and then temp equals no. Cur equals temp, and that should reverse the second half. Okay, so we have head 1 and head 2. Wow. No, it's not dummy though. res equals head. Well, head or head 2. This shit gotta be wrong, bro. Holy shit. Like, there's no way it's this much. Bruh, so you do start at head. I don't think this is right. Alright, that's time limit exceeded.
At the beginning, 1 pointer at the end, and using that we would build the output list where we would say, okay, the first pointer is the first position, the second pointer is going to be the next position, shift the pointers by 1, and basically rinse and repeat until we've done the entire list, right? Take this, put it in the next position, take this, put it in the next position, and then if we had an array with each value in the correct position, for example, if we built an array that looked exactly like this, then of course we could take the nodes themselves and create a linked list following that exact same ordering. But we can actually do this without using an array. We can do this without using extra memory. So let me show you how to do that. So the idea is going to follow similar to what I just showed you. We want to take the beginning of the list and merge it with the second half of the list, right? So this is the first half, this is the second half. We want to merge these together with alternating values, right? So this is going to go first, and then this is going to go second. So obviously, we're not merging them from the beginning. The second list is going to be merged from the end. But if we're not putting this in an array, how exactly can we do that? Because we're going to have 1 pointer at the beginning of the first array. We're going to have 1 pointer at the end of the second. I think I said array, but what I meant is list, obviously. We're going to have 2 lists. And so the first half of the list is going to be straightforward, right? We're going to take, this is going to be the node that goes at the beginning. Then we're going to take this pointer, shift it to the right. So that's pretty straightforward. But since we have a pointer at the end of the second list, and we take this node, we put it in the second position, right? We'll insert it somewhere in the middle over here. That's not impossible, right? We can do that pretty easily. But the problem becomes, okay, once we've inserted this node, then we want to move our pointer to this node, but the link is going the wrong way. The link is going in order, but we really want the link to be going in the opposite order, because when we traverse this second portion of the list, we're not going to be going from beginning to end. We're going to be going from end to beginning. So how can we do that without extra memory? Well, the easy way is, why not just reverse the links, right? For this entire second portion of the list, why don't we reverse every single link, and then we can do it pretty easily, right? There's no reason that we can't reverse the links. We're perfectly free to do that. So that's kind of what makes this problem a lot easier. There's going to be 2 phases to this algorithm mainly. We're going to take the second portion of the list, reverse it, and then we're going to take these 2 portions of the list and merge them together. This first, next this value, then this, right, et cetera, et cetera. The only other thing that I want to mention is when we're reversing the second half of the list, how do we know what is the second half? How do we know we've reached the second half, right? Starting from here is when we want to start reversing. How do we know once we get there? You can do it multiple ways. The easiest way is going to be a fast and slow pointer. So I'm going to have the slow pointer initially at the first and the fast pointer initially at the second node, we're going to be shifting the slow pointer by 1. We're going to be shifting the fast pointer by 2. And we're going to keep going until the fast pointer either reaches the end of the list or reaches the last value of the list. And once that is the case, we know that the slow pointer is going to be, if it's an even list, you can kind of run through it yourself and see that it does work. But if it's an even list, the slow pointer will be at the halfway point pretty much, right? It'll be at the end of the first list, right? So then what we'll do is say, okay, slow.next is going to be the beginning of the second half of the list. So that's what happens if we have an even number of nodes. What happens if we had a odd number of nodes? Let's see if the same thing works out for us. So if we had a slow pointer here and a fast pointer here, we'll shift the fast pointer by 2. It'll be over here. The slow pointer will be over here. Then we'll shift the fast pointer by 2 again. So it'll be at null over here. The slow pointer will be at this node. So I guess the question becomes, in this case, what's the second half of the list? Because obviously we have an odd number of nodes. Well, what we're going to say is this is going to be the second half of the list. Even though it's shorter than the first half of the list, it still works for us, because what the result in this case is going to be is basically, we have this second half of the list. This is the first half. We're going to take 1 at the beginning. We're going to take 5 in the next position. Then we're going to take 2 in the next position, right? We're just basically alternating. Then we're going to take 4 at the next position. And lastly, we're going to take 3 in the next position. So it does work out in this case. So you can see that, finding the middle of the list is something that can be done with 2 pointers, one fast and one slow. And in terms of actually taking these lists and merging them, it's pretty straightforward when you look at the picture. Actually coding it is a little bit tricky because we're going to have several different pointers. But just to give kind of the rough idea, we're obviously going to have a pointer here, which is going to be the beginning of the first list. We're going to have a pointer here, which is we're going to call the second pointer, the beginning of the second list. Obviously, the link here is going to be going the other way. What we're going to do is we're going to take, okay, this pointer dot next, right? 1 dot next is, instead of being set to this node, we're going to break this link, set it equal to the second node, which is 5. And then, of course, 5 is pointing at this node 4. So instead of having it point at 4, we want it to be pointing at this node, which was the original next node for 1. So we're going to do that. 5 is going to point at the second node. And then we're going to shift our pointers. We're going to take this pointer, set it to 2, take this pointer, set it to 4. Now, obviously, notice how we broke the link in both spots. So how are we actually going to be able to shift the pointers if we broke the link already? Well, we're going to have to save that link before we actually break it. We're basically going to have a temporary variable, which is going to point at this node, and a temporary variable that's going to point at this node before we actually break these links. I think that'll make it keep shifting. We have to be about that down. It can jump in and just find the actual down our pointer.
Yeah, okay, so that's exactly what I was thinking, but I just didn't know how to translate it exactly.
Manipulation is going well, but once you have that down and you kind of have this main idea down, coding up isn't too difficult. That being said, we can jump into the code now. Okay, so now let's dive into the code. You can see we don't have to return anything. We just have to modify the list in place. So that's what we're going to do. And remember, the first thing we want to do is find the actual middle point of this list. So we're going to have 2 pointers, slow and fast. Slow is going to be at the head of the list, and fast is going to be head.next. We're going to keep going while fast is non-null.
Fast is head.next? Huh. Wait. I'm a little confused. So you do start them both at the head, and then wow, fast. So you only check. I guess that is facts. Okay. Nah, low key, I'm bugging. I think I'm like I think this top part is good. Um wow fast. This makes sense doing while fast on next fast because I think this part is all good.
And fast has not reached the end of the entire list. And as that's the case, we're going to basically
Fast and fast.
shift each pointer. Slow is going to be shifted by 1. Fast is going to be shifted by 2. Okay, so that's great. So now we do have the beginning of the second half of the list. So we're going to have that second pointer. And remember, just like in the drawing picture, the beginning of the second half of the list is going to be the slow.next. So this is the second half of the list. But remember, now we actually have to reverse the second half of the list. Before I reverse it, I'm also going to say slow.next is going to be set to null, right? Because we're actually splitting this into 2 different lists. So that's how we're splitting it. Now we're actually going to be reversing that second half of the next is before half of the list. But remember, now we actually have to reverse the
Yeah.
second half of the drawing picture. The beginning of the second half of the list is going to be the slow.next. So this is the second half of the list, but remember, now we actually have to reverse. And so now we do have the beginning of the second half of the list. So we're going to have that second pointer. And remember, just like in the drawing picture, the beginning of the second half of the list, we're going to be shifted by 1. Fast is going to be shifted by 2. Okay, so that's great. So now we do have the beginning of the second half of the list. So we're going to have that second pointer. And remember, just like in the drawing picture, the beginning of the second half of the list is going to be the slow.next. So this is the second half of the list. But remember, now we actually have to reverse the second half of the list. Before I reverse it, I'm also going to say slow.next is going to be set to null, right? Because we're actually splitting this into 2
Mm.
different lists. Be set to null, right? Because we're actually splitting this into 2 different lists. So that's how we're splitting it. Now we're actually going to be reversing that second half of the list. So we're going to say while second is non-null, we want to set it to the previous node. Initially, the previous node is just going to be null, so we can set that as well. I think I can actually do it on this line. Previous is also going to be set to null along with slow.next. So basically, each iteration of the loop, we're going to store a temporary variable for second.next, but before we actually shift our pointer, we're going to say second.
Wait, but second equals slow dot next. But then we said slow dot next equals none. Oh wait, no, I'm tripping. Oh yeah, that's good. That's fine.
second dot next is going to be equal to previous, which is initially going to be null. And then of course we're going to update our pointer. So now previous is going to be equal to second, and second is going to be shifted to our temp, which is going to be the next node in the list. So with this loop, all we're doing is reversing the second portion of the list. Okay, so now is the part that the second half has been reversed. Now we're actually going to merge the two halves of the list. So the beginning of the second, right, we want to find that beginning of the second, which is going to be the previous pointer actually, because remember, after this loop is done executing, second is going to be set to null, but previous is going to be set to whatever the last node that we looked at was, and whatever that last node is actually going to be the new head of the second half of the list, similar to what we had in the drawing picture. So that's the second half. The first half is just going to start at the head, right? So what we can say is first is going to initially be the head, second is going to be whatever happens to be in previous. And so once you have this, all we're doing now is actually going to be doing the merge for the two lists. And so we're going to keep going until one of the pointers is null. And we know that the second half of the list could be shorter than the first half. So we're just going to say, okay, while second is not null, let's continue to merge these lists. So first, what I'm going to say is, remember, we're going to be storing the next nodes in temporary variables because we know we're going to be breaking those links. So the first thing we're going to do is temp1 is going to be first.next because we're going to be modifying that link. And temp2 is going to be second.next because we're going to modify that link as well. So now that we saved those, what we can say is, okay, first.next now is going to be reassigned to second, and second.next is going to be assigned to temp1 because we're basically inserting the second node in between first and first.next, which is what temp1 is. So we're basically inserting it between those. So that's kind of the merging operation. Now we just need to shift our pointers. So we can say, okay, first is now going to be set to temp1. Second is going to be set to temp2. And we can actually put it on the same line just to make our code a little bit shorter. So that actually is the entire code. We don't have to actually return anything, like I said, and you can see that this is very
Oh. Okay. I knew how to do the problem. I think just implementing it was a bit tricky. Uh, like this is fine. I mean, this is just a fast and slow pointer. Do you remember? I do have to remember to check fast and fast.next. Um, does make sense setting it equal to the next, splitting it off. Then reversing it is fine. Set. Okay, this is fine. Does it matter which one we put? Dang, it does. Why second? Second. Oh, second is always shorter or equal in length for the first half. Okay. Okay. Makes sense. Okay. Well, I think that's all I'm gonna do for today. It's already 1:30. Kind of want to sleep earlier today. Um, and we'll get started with remove emp node from end of list tomorrow. I'll see y'all later. Peace.